Good afternoon, good evening, everyone. Mm, Thank you for inviting ASTI to talk about current state of high-performance computing in the Philippines. Sorry for not being physically here in the APRP session due to scheduling difficulties. But anyway, good evening, and in behalf of my chief in the Research and Development Division of ASTI, I'm Jay Samuel Combinido, and I'd like to share to you recent developments in high-performance computing in our country. Here's the outline of my talk. First, I'll discuss the current state of our network infrastructure, which is the fundamental infrastructure supporting any form of scientific research in the country. In particular, I'll share about the only National Research and Education Network, or NREN, in the Philippines, which is PREGENET. Secondly, an introduction of the high-performance computing facility in ASTI as part of the core project. The facility is designed to aid local scientific community in their computational needs. It also aids them in storage and data sharing environments. Third are infrastructures supporting data collection, retrieval, and product generation. Actually, these first 3 points, actually form an intricate connection that enables our local researchers to do their work faster because of the availability of fast research network, compute servers, and research-grade datasets. Fourth is a brief overview of the research activities built on top of such infrastructures. And lastly, summary and future plans in relation to high-performance computing. So let's talk about PREGENET first. PREGENET, which stands for Philippine Research, Education, and Government Information Network, is the only REN in the Philippines. It has been in operation for nearly 2 decades now, and what you can see on the screen is the current local and international connectivity of PREGENET. Notably, it is connected to an active member of major international RENs such as TAIN and APAN. TAIN connection is established through a 10 gigabit link to Hong Kong, if I'm not mistaken. And meanwhile, we are connected to APAN through Japan. Due to this, we have indirect connection to Transpac and CINIC in the US. And apart from that, PREGENET is also actively improving connectivity of local universities in the Philippines so that they can take advantage of the existing large connections outside the country. These links have constantly improved over the years as demand increases, and this year we'll be expecting future upgrades. For instance, we want to establish a 10 gigabit link to Global Switch so that we can connect to Singaran and SGIX. Hopefully this will be in operation by second quarter of this year. Moreover, links to US and Guam will be established as well, 10 gigabit to the US and 1 gigabit to Guam. I can talk about this much in detail, but I'm sure Sir Bani Lara of ASTI can provide much more information about these upcoming upgrades. Another interesting facet is the Luzon Bypass project between the Philippine government and Facebook. So what you can see here is actually a link that bypasses the west coast to the east coast of the Philippines. So it is expected to provide 2 terabits of bandwidth to Hong Kong and Los Angeles, USA. Okay, now let's move on to the high-performance computing facility in ASTI. Currently, the HPC facility is operated and maintained by the Computing and Archiving Research Environment Project, or CORE, since 2014. CORE is a successor of an earlier eScience Grid facility established in 2008. The compute facility is located in ASTI, and what you see here is the outside view of the data center and 2 of our technical personnel operating the data center. So just to give you a bit of a history of or about CORE in general, is that CORE was conceptualized to address 4 user-driven needs. Some of these were actually based on experiences gained from its predecessor, which is Philippine eScience Grid. These 4 are storage, compute, cloud, and data collection and sharing. These are the needs, these are the basic blocks that form the services that Core offers now to its stakeholders. HPC services, storage services for data archiving, cloud services for automation and web applications, data catalog for harvesting and sharing research data from and to the academe and local government. Before, we also offer co-location services where we assume maintenance of third-party servers, especially coming from universities and academic projects with insufficient funds for server maintenance and operations. For almost 10 years, since our first HPC infrastructure in the Philippines, resources have grown quite substantially. This is actually in response to the growing computing and storage needs in the country. So as of 2017, we already have 3,600 CPU cores, 20,800 CUDA cores from 7 NVIDIA GPUs, 13 terabytes of RAM, and 2.4 terabytes of storage. We'll be adding more resources, I think, at the start of 2019. Last year, we have established a second site as well, intended for our cloud services. Specifications are shown on the screen. Okay, it's composed of compute node, block storage, object storage, network node, and it has a total of 796 cores. 580 of those are usable, and approximately 4 terabytes of usable storage. Okay, this second site is run on OpenStack, and the equipment are stored in the ICT department of the Philippines. Here are just a few pictures of the equipment. Also last year, Pedro, or the Philippine Earth Data Observation Center, went operational. Its main function is to receive, process, and distribute spaceborne imagery for various applications. Pedro receives the data for the Diwata-1 microsatellite of the Philippines. It also subscribes to several commercial satellites like COMSAT 3, COMSAT 5, Dove, and among others. Pedro and Datos and the Datos project are working hand in hand to generate derived satellite products, especially for disaster mitigation and natural resource assessment. With these developments, we are getting ready to beef up storage resources even more. On top of these infrastructures are research applications, and some of these are ERI, working on rice genomics, land cover classification, WebGIS applications by NOAA, flood detection. We also have people working on molecular dynamics, weather and climate modeling as well. We also have applications related to machine learning applied to domains such as networking, weather, and even in the field of law. So in summary, the Philippines is continually investing on increasing network connectivity, both locally and internationally. It also is investing on increasing compute and storage resources, as well as the acquisition of several research datasets. This is to further boost e-science research and development of the country. An upcoming goal for CORE is to establish an even larger computing facility to keep up with the demand. And this year, actually, we are reaching an approximately 80% utilization of the HPC cluster. This is actually our cue to procure more resources. Thank you for listening. If you have any questions, don't hesitate to email me, jsamuel@asti.dosd.gov.ph or greedops@asti.dosd.gov.ph. Thank you.